Hello, everybody. Welcome to today's lecture. So today we're going to talk a little bit more about decimals. We're going to dive into the decimal operation. So, if we have two decimals, how do we add them together? Subtract, multiply, divide. And once we know how to do that, then we can apply what we previously learned about equations to equations that now have decimals in them. Okay. So I did mention very briefly at the end of the um, last lecture that decimals do have a special property where if we multiply by 10, okay, so if we do something like this, that's equivalent to moving the decimal over to the right one time. So we would get 52. And if we divide by 10, this is equivalent to moving it to the left one time. So we would get 0.52. And we're going to use this fact quite a bit when we are doing some things like division. And um, you could also use this for multiplication as well to make some of those problems easier. You could break it up into a problem where you're multiplying by 10 for one part and multiplying by something else for another part. But let's dive in and start with addition first, naturally, because that's usually what we start with. Okay. So addition really shouldn't present any additional problems from the addition we were doing in chapter 1, because there's really not anything more to it. If you remember back in chapter 1, we were doing addition with whole numbers. So say like 53 plus 47, right? 53 plus 47. So what we would do is we would line up the place values. So we line up the ones place, line up the tens place, and so on. If we had more digits. And then we would add the ones together and we would carry any additional place values over to the next appropriate place value. And here we get 10 again, so we'd have 100. Okay. Decimals is going to work the exact same way. If we had 5.3 plus 4.7, we're doing the same thing. We're still putting the numbers on top of each other and we're making sure to line up the place values. The only difference is now we have some additional place values on the other side of the decimal. So we have to make sure the tenths place is lined up as well as the ones place. Okay. And the decimals themselves should also be lined up. Okay. Which should make sense because that's really just a barrier between the tenths place and the ones place. So if the tenths and the ones place are lined up, the decimals naturally will be lined up as well. So, when we do this, we would basically get the same thing, but the difference is now we want to drop the decimal straight down into our answer because this is the tenths place for our answer, right? So when we go over here, this is going to be the ones place, so there should be a decimal between the 1 and the tenths place. And then again, we're going to get 10. So we get 10.0 or just 10 for this one. Let's take a look at another one. What if we had 2.35 plus 1.7? Okay. So we want to take the numbers and we want to line up the place values. Okay. So this might look a little strange because we don't have the same number of place values, but it all is all lined up properly. The ones places are lined up, the decimals are lined up, the tenths places are lined up. On the second number, we don't have a hundredths place, so we just kind of assume that there's a 0 there, right? Remember, we can put as many zeros as we want on the end of a decimal. It doesn't change what number it is. So you can write it in there if you'd like to, or you can just imagine that it's there. So now we do 5 plus 0 is 5. 3 plus 7 is 10, so we write the 0 and carry the 1. We drop the decimal place straight down, and then we have 1 plus 2 plus 1, which is 4. So we end up getting 4.05. Okay. So there's not a whole lot going on that wasn't going on when we were dealing with whole numbers. The only difference now is we just have potentially more place values to account for that we have to make sure are lined up. Okay, let's do one more example. 13.385 plus 0.921. Okay. So we want to line them up. Okay. Whoops. 13.385. So this one, we line the decimals up. And then we have 9 to 1, which is our tenths, hundredths, and thousandths place. Okay. So we don't have any whole numbers here, so we can just leave it blank. Again, you can write in some zeros if you don't like leaving it blank, or you can just imagine that there's a 0 there or whatever. So we do 5 plus 1 to get 6. 8 plus 2, we get 10, so we write the 0 and we carry the 1. 1 plus 3 is 4, plus 9 is 13. And now we drop the decimal place straight down. 1 plus 3 is 4, and then we just have 1 by itself, so that's 14. Okay. So we end up getting 14.306. Okay. All right. So just like addition, subtraction really isn't going to be too much different from whole numbers either, because subtraction pretty much work the same way, right? We just line up the place values and subtract the individual place values. So that's exactly what we're going to do here. And we just have to make sure that the place values are lined up. So if we have 2.2 minus 1.3, okay, so we just want to line them up like this. And, if that decimal wasn't there, this would be just like doing 22 minus 13, right? And I mean, that's essentially what we're doing. The process is exactly the same. We just have to remember to drop the decimal place down. So we need to borrow for that too, because we can't do 2 minus 3. So we borrow 1 from this, just like we would with whole numbers. And we do 12 minus 3 to get 9. And then we drop the decimal place straight down, and then 1 minus 1 is 0. So we get 0.9. Okay. Just like if we were doing 22 minus 13, we would get 9. The only difference is now we have a decimal. One thing that could be potentially tricky is what if we have, let's make it a little bigger, let's say 8.4 minus 3.35. Okay. So we'll line everything up here. And then we have this. Okay. So this could maybe be a little bit tricky because, notice we don't have a tenth or a hundredths place in the top number. And we really need one there because we need to do that number minus the 5. But luckily, like I said, we can put as many zeros as we want on the end of the number. So we can just go ahead and make it 8.40, and then we can just proceed as normal. So we have to borrow from the tenths place here. Okay, so we do 10 minus 5 is 5, 3 minus 3 is 0. Drop the decimal straight down, 8 minus 3 is 5. So we get 5.05. Okay. So again, really nothing is changing. It's just like doing this with whole numbers. Okay. When you're looking at a calculator, any calculator should have a decimal place button. So make sure to use that. Okay. Let's move on to multiplication. Because multiplication, it can be a little bit weird. So the process for multiplication, let's do 1.5 times 10. Okay. So the process for multiplication is 1, do the multiplication while ignoring the decimal. 2. Then we're going to count the number of decimal places in the factors. Okay. So in the 1.5 and the 10. And then we're going to put that many decimal places in our answer. Okay. So it's a little bit different. But step 1 is just ignore it. So let's go ahead and do that. By the way, the one I chose, if we were just doing 1.5 times 10, we know we're just going to move the decimal to the right once, so we should get 15. So let's do this method and make sure we get 15. So if I was just ignoring the decimal, this would be like doing 15 times 10. So we would do 0 times 5 is 0, 0 times 1 is 0. Now, when we go down to the next place, we need to put a 0 in here because we're going over to the tens place. Then we do 1 times 5 is 5, 1 times 1 is 1. Add them together, we get 150. Okay. So this is our answer, 150. Number 2 says count the number of decimal places in the factors. Okay. Total, we have 1 decimal place, right? We have this is our 1 decimal place, right? When we say decimal place, we mean how many numbers are to the right of the decimal. Number 3 says put that many decimal places in our answer. So we have 1 total, so we should put 1 here. So we go ahead and put a decimal right here. Okay. And that makes it 15.0 or just 15, which is what we would expect the answer to be. Let's try 2.3 times 1.4. Okay. So first we're going to ignore the decimal places and just do this as if it is 23 times 14. 3 times 4 is 12. 4 times 2 is 8, plus 1 is 9. Okay. Now, whoops, sorry. 1 times 3 is 3. 1 times 2 is 2. Okay, so we got that. 322. And then we're going to go up here and count how many decimal places we had. Well, we have 1 in 2.3, we have 1 in 1.4, so altogether we have 2, right? So now we're going to go down to our answer and we're going to add 2 decimal places to it. So that means that we should have 2 numbers to the right of the decimal, meaning we're going to put the decimal right here. So our answer is 3.22. Okay. Okay. So this is just multiplication as normal, but with that 1 extra step at the end. Let me just make sure I haven't forgotten anything here. That's all I'm doing. All right, let's do one more. Let's say we have negative 7.78 times 4.6. Okay. So now we have a negative in here. Well, we know a negative times a positive is a negative. So we can kind of just forget about the negative and then add it in at the end. Okay. So let's go ahead and do the multiplication, forgetting about the negative for now, but we should remember it when we come back at the end. Okay. We should, it might be helpful to add a 0 here, so that we have the same number of digits in the top and the bottom numbers, just to keep track of them a little bit better. Okay. So we're going to do the multiplication as normal, ignoring the decimal. So we have 0 times 8, 0 times 7, 0 times 7. And then we move down to the tens place. Okay. 6 times 8 is 48. 6 times 7 is 42. Sorry, 42 plus 6. Plus 42 plus 4 is 46. And then same thing on this one. And now we're moving over to the hundreds place. I'm saying hundreds because we're pretending the decimal isn't there. All right, so now 4 times 8 is 32. 4 times 7 is 28, plus 3 is 31. 4 times 7, same thing, 31. Okay. So we get this, we got 0, 8, 8, 7, 5, 3. And now we go back and say, okay, there's 2 decimal places in the first number. There's 2 in the second one. So altogether, we should have 4 decimal places. So this is what we get, 35.788. And then also remember the first number was actually negative. So this should be negative 35.788. Okay. All right. So now we want to look at division. So remember, when we were converting fractions to decimals, we kind of already saw a glimpse of this, right? Where we added a decimal place into the top number, right? Like when we were doing 1 divided by 2, say, we said 2 goes into 1 0 times, and then we added a decimal place to keep it going. And we did that, we put a decimal in the answer also. And we had 2 goes into 10 5 times, and we were done, right? So this is kind of what we want to do here. We just have to make sure that the decimal place in this number and the decimal place in the answer line up. Okay. So if we were doing, say, 0.8 divided by 4, okay, and we would do it with long division, and we'd say 4 goes into 0, 0 times 4. Okay, bring the 8 down, but we need to line up our place values so that there's a decimal in our answer. Okay, so 4 goes into 8 2 times, and then we're done. Okay, so our answer just ends up being 0.2. So there's really nothing going on in this scenario. If we have 10.2 divided by 4, let's say, okay, So we have 4 goes into 10 2 times. And we have 2 left over. Now we bring a 2 down. Once we cross over the decimal, we should also put a decimal into our answer. 4 goes into 22 5 times. Okay. Now we are out of digits. We don't want to mix decimals and mix numbers or write a remainder here. We always want to keep this going so we have a decimal answer. So we'll add a 0 onto the end until we end up getting a 0 remainder or it starts repeating. So 4 goes into 20 5 times. Okay. And then we're done because that goes in evenly. So 10.2 divided by 4 ends up being 2.55. Okay. Okay. So these were all scenarios where we have a decimal and we're dividing it by a whole number. So we can see, like in this case, there's really nothing else extra to do besides for carrying that decimal straight up. Okay. What about though if we're dividing by another decimal? Well, then things might get a little trickier. Okay. Let's say we have 10.5 divided by 0.5. Now this is a little bit weird, right? Because we're saying, okay, 0.5 goes into 10 how many times? Okay, which is a little bit weird. Or 0.5 goes into 1 how many times? Like we can do this, but it's going to be weird. So let's not do it this way. Let's change the problem into something easier. How would we do that? Well, first of all, this is 10.5 divided by 0.5, right? Remember the multiplying by 10 trick. That says if we multiply by 10, it moves the decimal over 1. And then remember also our equivalent fractions trick. If we multiply the same number on the top and the bottom, then the quantity here hasn't changed. So whatever this quantity is, if we want to, we can just go ahead and multiply by 10 divided by 10. Okay. This doesn't change what number this is because 10 divided by 10 is just 1, so we're really multiplying by 1. But this has the advantage of now, okay, if we multiply by 10 on the top, that's going to move the decimal over 1. And if we multiply by 10 on the bottom, that's going to move the decimal over 1. So we see that 10.5 divided by 0.5 is really just the same thing as 105 divided by 5, which it's a much easier problem to do. Now we're just dividing two whole numbers. Okay. So 5 goes into 10 2 times. Okay, 5 goes into 5 1 time. And then we're done. Okay. So it's that simple. If you want to confirm on your calculator here, let's do 10.5 divided by 0.5 and we get 21. Okay. Okay. Let's do one more example with that one. Hey, what if we were doing 33 divided by, let's say, 1.1. Okay. So again, we want to just multiply the top. We just want to multiply both numbers by 10 essentially so that we can move the decimal place on this one, and then we don't have to deal with the we don't have to deal with thinking about like 1.1 goes into this how many times. So you don't have to write it out like this every time. Instead, you can just go ahead and move the decimal until you have whole numbers, which here we'd have to put a 0 in here. So we'd have 11 going into 330. Because remember, you can put as many zeros as you want here. So you just move the decimal over and go ahead and do it like that. So let's go ahead and, I mean, now we're just doing 330 divided by 11, so it's no different. Like once you do this step, it doesn't, there's nothing different than what we were doing before with whole number division. We are going to have to keep it going and make sure that we do get a decimal as an answer, though. So 11 goes into 33 3 times. Okay, so we get a 0 remainder. 11 goes into 0, 0 times. 0 times 11 is 0, and then we're done. Okay, so 33 divided by 1.1 is 30. Okay. Okay, so looks like we are good with this section. Let's go ahead and look at 5.4, which is, like I said, talking about combining what we were doing with equations now with decimals. Okay. So we could just do something like this. What if we have negative, or y plus 2.3 is equal to negative 4.7? Okay. So the process is going to be exactly the same as when we did these kind of equations with whole numbers. Now we just have decimals, though, so we have to think about our decimal operations. So we would have, we still want to get y by itself, so we're going to subtract 2.3 on both sides. Okay. So the only difference is now we have to think about, okay, what's negative 4.7 minus 2.3? Okay, this can get a little bit tricky. So you really have to think about, okay, well, what's going on with the negatives here? Okay, negative 4.7 minus 2.3. This is like the negative version of 4.7 plus 2.3. So you can just do 4.7 plus 2.3 and then put the minus sign at the end of it. Okay. To do this kind of like with mental math, okay, I just like to put the 0.3 on there first, and that brings me up to 5. And then I have 2 more to go, so that brings me up to 7. So all in all, we're going to end up with negative 7 here. Okay. At this point, you can also do these with a calculator. I'm more concerned with you doing it by hand in 5.2, but once you get the hang of it, you can start using a calculator. And I mean, in this section, there's really just examples to do, so let's just do a few examples, and then we'll be done for the day. Say we have 10y plus 5.3 equals 25.3. Okay. So we just want to get this part by itself. So first we should subtract the 5.3 on both sides. Okay. So we get 10y equals 25.3 minus 5.3 is going to be 20, right? Because we're just taking the 5.3 part off. And now we're dividing by 10 on both sides because we want to get rid of the 10. So we get y equals 2. Okay. So this is all the equation stuff we've been doing this whole time, just in a different context now. Let's say we have 2.35x minus 1.07 equals 5.68. Okay. These numbers are pretty complicated, so I would recommend using a calculator for this one. But for the process, we first want to get rid of the 1.07, so we add that to both sides. Okay. So, I mean, this one you can kind of line it up and do it by hand if you would like to. So we get 6.75. And then we need to get rid of the 2.35, so we divide by that on both sides. Okay. So in your calculator, I would just do 6.75 divided by 2.35. You're going to get a really long decimal. So we're going to round off to 2 decimal places. So we're going to get 2.87. So the reason I changed it to like a squiggly equal sign here is because that's what we use for approximately equal to, which is what we should use if we're rounding. Okay, I'm not going to be picky about that. If you just use an equal sign, it's fine, but just know that technically you should be using this. Okay. Okay. Um, so that's going to be it for today. We still have more in chapter 5 to do. There are 3 application sections of chapter 5 which are very important because they actually have like some big math ideas in them. Like rates and ratios and square roots. So we'll talk about those next time. Um, so yeah, so we're basically done with like the decimal stuff. Now we're going to look at applications that we just couldn't really look at before we talked about decimals because they involve decimals, but it's not really new decimal stuff. So the rest of this chapter will be applications. So thank you guys for watching this video, and I will see you next time.